Hey guys, in this video I'm going to go through how to find the area of a region bounded by a curve and the x-axis. In my last video I covered some examples of how to find the area under a curve when the curve was above the x-axis. There's a link to that video in this post if you want to watch it. We learned that the area under a curve is found by the rule the integral from a to b, where a and b is the lower and the upper bound of the interval of the function f of x dx. However, you can only use this rule if and only if the curve lies above the x-axis for the given interval. When the curve lies below the x-axis, like the first graph on the screen, then if we integrate this rule, we're going to get a negative value. And because we need an area of a region, we cannot have a negative area. And so here's the key concept for this video. Whenever you're finding the area of a region that is below the x-axis for a given interval, you must multiply the integral by a negative. Multiplying the integral by a negative will result in a positive value. Another way you can write the integral so that it evaluates to a positive value is to switch the terminals within the integral. And so this is equivalent to writing as the integral from b to a of the function f of x dx. If you decide to use the second method, then you don't need to include the negative sign. Looking at the second graph, what if the area of the region required was a combination of areas above and below the x-axis? In this case, you need to calculate each region by a separate integral for each area above the x-axis and a separate integral for each area below the x-axis, and then add the areas together. And so the area for the region of the second graph can be written as the integral from a to c of the function f of x dx. And now because we're using the boundaries a to c, we need to place a negative in front of this integral. And then we add this to the area of the region above the x-axis. And this is going to be the integral from c to b of the function f of x dx. Another way we can write this is to say the area is equal to the integral from c to a of the function f of x dx. And so this time we don't need to include the negative sign. And then plus the integral from c to b of the function f of x dx. Now, a common mistake to avoid is to write the total area as the integral from a to b of the function f of x dx. This is going to give you the wrong answer. You must find each area above and below the x-axis separately and then add it all together. This was it for the theory part. Now let's do some examples. Part A. We need to calculate the area of the shaded region. Notice the curve y is equal to 1 minus x squared is below the x-axis for the interval from -2 to -1. And so we can write the area is equal to the negative of the integral from -2 to -1 of 1 minus x squared dx. And now we can evaluate. And so this is going to be minus x cubed on 3 from -2 to -1. To simplify the calculations, I'm going to divide by a negative from the inside. And so we can write this as x cubed on 3 minus x from -2 to -1. Subbing in the terminals, this is going to be -1 cubed on 3, which is going to be -1 on 3. And then minus -1, which is going to be +1. And then -2 cubed is -8, and so this will be -8 on 3, and then -2 is going to be +2. This is going to be 2 on 3 minus -8 on 3 plus 2 is the same as -8 on 3 plus 6 on 3. And so this is going to be -2 on 3, which is equal to 2 on 3 plus 2 on 3, which is equal to 4 on 3. And so the area of the shaded region is going to be 4 on 3 square units. Part B. The shaded region is from pi to 3 pi on 2. Notice the curve is below the x-axis for this interval. And so we can write the area is equal to the negative of the integral from pi to 3 pi on 2 of sine x dx. Evaluating this is going to be minus cos of x from pi to 3 pi on 2. Taking out the negative, this is going to equal cos of x from pi to 3 pi on 2. Now subbing in the terminals, this is going to be cos of 3 pi on 2 minus cos of pi. Cos of 3 pi on 2 is equal to 0. And so this will be 0 minus cos of pi is minus 1. And so this will be minus 1, which is going to equal 1. And so the area of the shaded region is 1 square unit. Find the area bound by the x-axis and the graph of the following function. Looking at the graph, the area bound by the function and the x-axis is going to be these two regions. Notice the first region is above the x-axis and the second region is below the x-axis. And so we need to write the total area as a combination of two separate integrals. One way we could write the total area is the integral from minus 2 to 1 of the function y dx minus the integral from 1 to 3 of the function y dx. If we use the other method, we can write this as equivalent to the integral from minus 2 to 1 of the function y dx and then plus the integral from 3 to 1, so we're swapping the terminals of the function y dx. Setting this up in the calculator, we can work this out. And so the total area is equal to 253 on 12 square units. Find the area between y equals x on x squared plus 2, the x-axis, x equals minus 1 and x equals 1. To find the required area, it's best to first have a look at the graph of this function to see whether the curve lies above or below the x-axis for this given region. And using the calculator, we can see the graph of this function. Looking at the graph, the curve is below the x-axis from x is equal to minus 1 to 0, and it's above the x-axis from x is equal to 0 to x is equal to 1. And so we can write the total area is equal to, or one way we can write it is the negative of the integral from minus 1 to 0 of the function y dx plus the integral from 0 to 1 of the function y dx. Or we can write it as the integral, the positive integral from 0 to minus 1 of y dx plus the integral from 0 to 1 of y dx. Setting this up in the calculator, we can work this out. and so the total area is equal to log E of 3 on 2 square units. And just as a side note, looking at the graph, this function is symmetric, and so we could also write the area required as 2 times the integral from 0 to 1 of the function y dx. And that's it for this video. If you guys are serious about your study score, then you need to start learning how to answer exam style questions. To practice exam style questions related to the topic of finding the area under a curve, then log into the Maths Methods Club. And from the main topics, you can select integration. And then from the subtopics, you can select area under a graph. There's plenty of questions you can try. If you wanted to filter by question type, go to question type and select take-free, multiple choice or extended response. Good luck, and I'll see you guys in the next video.